Hey guys, I'm Pat Kelly. Okay, in this problem, they've given us the f of x and g of x, and what we're asked to do is to verify that they are inverses of each other. And we need to do so algebraically and then also graphically. So I'll start with my algebra. And to confirm that the two functions are inverses algebraically, what you're looking at is our good old composition, right? F of g of x. We've done enough of these, I hope. I'm taking all of g of x, putting it in for f of x. So I do see, to start, a 7 times the input, which is going to be the entire g of x, x minus 1 over 7. Close the input, here's where I'm at, plus 1. And then, as always, simplify, right? So let's see, the 7s are going to divide out. I'd be left with x minus 1 in parentheses, plus 1 outside of parentheses, and that equals x. And that's good. That's what we'd want. That's confirmation. Confirmation that these two functions undo each other, right? This is saying whatever your input of x is, you'd run it through the g machine. Whatever comes out, you put it into the f machine, and this is telling us that what's going to come out of that is x. So in other words, these two functions undo each other. What goes in is the same thing that comes out. All right, I wouldn't stop there. That confirms that g inside f works. I'd also want to do the other order, g of f of x. And you should get that same result of x, but a different way. This way is going to be f inside of g, so I'll take all of that and put it right here for x. 7x plus 1. That's my argument here. And then there's a minus 1, big divided by 7. Right? Simplify. Plus 1 minus 1 is going to go to 0. All that's left up top is 7x. We still have the 7 on the bottom, dividing out nicely. Good. We get the x that we wanted, and that's confirmed. Right? Okay, so now, algebraically confirmed. We also want to do this graphically. They asked us to. So what I'm going to do is set up a little xy table for each of these. Let's pick some hopefully friendly values of x. Like I'll do 1, 0, minus 2. Good old xy tables. We just do some plugging and chugging. 1 plugged in here. Looks like 7 plus 1, which is 8. 0 plugged in here. Looks like 1. And a minus 2, it's a minus 14, plus 1 looks like minus 13. Good old arithmetic. Now we take those points and plot them. I'll try to be careful with this. I was trying to be kind of neat in the setup here because we're asked to verify that these two functions are inverses of each other graphically. So try to make your graph neat enough that you can see the cool things that are going to happen. So I'll be careful with my scale here. 1, 8 looks like it's about there. 0, 1 would be right there. And negative 2, negative 13 looks like it would be right about there. Let's see how I did. If they line up in a nice straight line, I'll graph. Looks pretty good, I think. All right, so there's my graph of f of x. Let's do the same thing for g of x. And I'm going to do a little bit of a trick here. I mean, not really a trick per se, but for my xy table, this time, I'm going to pick x values of 8, 1, and minus 13. So the trick, if you will, is I'm grabbing my y values from the earlier table. You might have noticed that. And watch what happens. 8 plugged in here, 8 take away 1 is 7, divided by 7, that's 1. You end up with the corresponding x value from the earlier table. Not a coincidence. Plug in a 1, 1 minus 1 is 0, divided by 7, still 0. Minus 13 plugged in, down to negative 14, divided by 7, and I get a negative 2, right? Now plot these points in the same set of axes. So I'm going to do 8, 1, which would be about here. And 1, 0, which looks like it would be right there. and negative 13 and a negative 2. Right about there. I'm trying to be careful. I told you that. All right, let's see if I was careful enough. Let's see if these dots line up and give us a nice linear graph to represent g of x. I did a pretty good job. I do say so myself. All right, there's my g of x function. And the problem is still saying, okay, confirm that these are inverse functions graphically. I've got my graphs, but so what? Where's that coolness that you promised me, right? What am I seeing here? So I'm going to draw one more thing on the graph. And I'm trying for a really nice 45-degree slant. If I could, if I can get it, I mean. And I'm actually going to draw that even as a dashed line, if I'm good enough here to do this. Just a quick dashed line. And here is the point, very key point. What we just drew was the line y equals x. And if these two functions they gave us are inverses of each other, then the coolness about their graphs is they should be mirror images of each other through that y equals x line. And I think it looks pretty good here. If you picture that dotted line as a mirror, the orange is the reflection of the pink and vice versa. It's exactly what we want to see if these functions are inverses of each other. Okay? All right, try some more on your own. I hope that process helps.